So what I'm going to do is construct the level and store all the level information in an array. Okay, normally you're used to an array like this where you create an array and you'll set the size of it, and then if you want to call an item in the array, you just ask for it at a position. So just say at position, if this was an array of integers, just say at position 0 we had some text, and just say at position 0 we had the number 5, position 1 we had the number 11, position 2 we had the number 4, etc, etc. Okay, so that's a one-dimensional array. And I should bring up a notepad to show that. Okay, so if we said something like my array this would be array of integers, and we'd have the square brackets like that. Of course, that would be a variable. Okay, so that is what's known as an array, a built-in array, or a one-dimensional built-in array. Okay, so how is this going to be different? Well, I want to store values going this way and going this way. So we need to set up a two-dimensional array. So instead of something like this, we're going to also be including some other values. Okay, and then you look up the array the same way. This would have an index of 0, this would have an index of 1, this would have an index of 2, and you get the idea. So if we're talking to this array, we don't ask for array at position 0, we have to ask for array at position 0, 0. So we're just basically feeding it coordinates to read whatever is at that position. And this is how it would look. So a variable, this will be my 2D array. 2D array. Array of integers. And right there, that's how we specify that it's going to be a two-dimensional array. We've got a comma in the middle. Now to initialize this, we set the sizes. Normally if you set the size of a normal array, okay, just say we wanted an array with a size of 12. And my typing's all over the place tonight. Okay, that's how we'd set the size of an array there. So to set the size of a two-dimensional array is pretty much the same thing. Just say we wanted a 12 by 12 two-dimensional array. And there we have it. Okay, so let's just get into the project and start building some scripts. First script is going to be my level manager. And it's still, no, it's now the 24th. Good morning. Okay, so just like I said, let's set up some arrays to hold all our level data. So let's create a variable, level array. This will be an array of integers. And to set the size of the array, I'm going to make this possible through the inspector. So I'm going to create another variable, level size. This will be a type vector2. So I have an x and a y equals vector2. Now, so roughly on the size, okay, let's just use some standard widescreen numbers. If I said this was 16 by 9, but I wanted it odd because we want these unmovable, unexplodable barriers every odd number. So if I said it was going to be 16 by 9, and Well, they're uneven, so let's make that 17 by 11. But then we also want the borders. Okay, so adding one for each side, that would be 19 by 13. So that's the size that I'm going to set my array. 19 wide, 13 deep. Okay, so in the start, we want to set up our level. So I'm going to create a function. And I want to make sure that I'm not trying to build a level that's not integers, because my array needs to be constructed and defined by an integer. So let's just constrain that level size. Level size x equals math f dot floor to int. Yep. And level size dot x. So this is just going to round the number. So if someone put in 19.3 or 19.7, it's just going to round it off to an integer, floor to integer. So if it was 19.7, it would bring it down to the floor 19. Okay, let's do the same thing for the y. Okay, the reason I'm doing this is because vector3 can store floats, but when I'm setting the size of an array, I mean, if this was an array of strings, you can only set the array values by integers. So we're just making sure those level sizes are integers here, and now we can set the size of the array. That's why it's not coming up. Level array equals new integer, and I'm going to use the level size x. And that's it. Making a lot of typos. So what are we going to do with this level information? Well, first of all, we're going to assign different values for integers for this array. Okay, so I'm going to imagine something like unwalkable, something that's steel that can't be blown up or walked upon. I'm going to give that an integer value. And then these rocks that can be blown up, I'm going to give it another integer value. And walkable areas with nothing on them, I'll give them another integer value. So I can read through this level array, and I'll know exactly what is in what position on the screen. So let's create a couple of for loops that we can populate information in our level array with. Okay, so that's going to loop through for the y, this 13. We need to make another loop for the x. Okay. And before I can visually show what we are doing here with this array, we need to create a couple of prefabs. And like I said, each item on the level is going to have a different integer value. So for example, I said if an area was unwalkable, I'm going to call it steel, just so I know what I'm referring to and you know what I'm talking about. but I'm going to give steel an integer value of 2. So if somewhere in this level array is stored the value 2, then I can translate that to meaning it is a steel block and it's unwalkable. So let's create a prefab for that. Alright, save that out. Let's go back to Unity and make that prefab. So I'm just going to create a cube. I'll call it steel block. Zero out its position. Now for simplicity's sake, I'm going to keep everything at a scale of 1. Okay, and I've already created that steel material. So there we have it. There is our steel block ready for our level. I'm just going to drag it down into my prefabs folder, and I now have a prefab. Let's delete that. Let's just create a scene for the level so we can start building things. Game objects. Let's create empty to store or to hold our level manager script. Drag and drop the level manager script on there. Then we have our vector 2 with the size of our two-dimensional array and our steel block. Let's drag in that. Okay, save the scene. Let's just call it level 0. Okay, so we should just demonstrate what this two-dimensional array is doing at the start. So let's make this a variable for instantiating blocks. Var block of type transform, because we're going to be instantiating. Alright, so let's put this all together and see what's happening here. So let's just create a steel block in every single position for our array and see what our array looks like and how it's going to start working. So first of all, I'm going to populate the level array. And I'm going to be setting the value at position x, y. And as I've set up here, all my steel blocks are going to have a value of 2 in the array. So when I read back the array, and it says at position x, y, you have a value of 2, I know it's a steel block. Okay, let's instantiate one of these blocks. Instantiate steel vector 3. I'm going to set it at the x position. Now I'm going to keep it in the the xy plane. Everything is going to be set to 0 on the z. So it's not going to be flat, just so we don't confuse things between the x coordinate, the y coordinate, and then translating the y coordinate to be the x coordinate if we had it flat on the ground. I'm just going to leave it up in the air vertically. And set it to a default rotation. Now I've instantiated it into a variable so I can do other things to it, like set the name, so that'll give it a name of steel underscore with the x coordinate position and the y coordinate position. And finally, just to keep our hierarchy tidy, I'm just going to make it a child of the level manager object. Because we already have the transform, we can just say block parent equals transform, whatever transform this script is attached to. Okay, so we should start to see some things happening with that. No compiler errors. So if I hit play, what's going to happen? Well, we should get a whole grid of steel blocks that is 19 by 13. And is my computer slow? No. It's because we haven't called the function. So at the start we want to set up the level. We have a setup level function, but we're just going to create an array, a two-dimensional array of blocks. Now let's hit play. Fantastic. A bit close. But there we have it. If I expand that, we'll see all our child objects. There's our steel block at 0, 0, 0, 1, because it's X and then Y. So there's a visual demonstration of two-dimensional array. Looks like we need a light in there. Okay. Let's keep mine up in the air, out the way, and save the scene. So here's the start of what's going to become my BlastMan level. Now we need to add some considerations in for only instantiating these steel blocks in certain positions. I want to instantiate a steel block for every border, and then every odd coordinate, and I will instantiate a block there. So let's look into adding that into our loop. So that was our example. Let's just pop it out of the way for the moment. Set the borders. So let's do some conditional statements to check what's going on here. So if x is equal to 0, or x is equal to, we have the maximum size of our level here, minus 1, because remember the length, an array starts from 0. So if we said an array had a size of 12, it would count 0 to 11. So we need to have the minus 1 in here, and that's all for the x. Now let's set the same thing up for the y. Just copy that out. Or if y is equal to 0, oops, missed it. If y is equal to 0, or y, I'm glad I'm reading this, is equal to level size y minus 1. Then let's do our steel block instantiating. Alright, so now we should just get a border of steel blocks. Okay, there we have it. Here's our frame, our border. We're starting to build our level already. Okay, and just like I said, how I remember it, there's always a solid block every odd brick along. So let's program another conditional statement for that. Else if now we're going to be instantiating steel blocks in there, so I can keep all that. But what are the conditions? Okay, I'm going to use modulo. Let's just type it and then try and explain it. If x percentage 2 is equal to 0. Now what does that mean? So we're going to take x and we're going to divide it by 2. Now when we divide it by 2, no, it's not divided by 2. It's divided by 2 as many times as it can. It's the lowest common multiple. Okay, so if x was 5 and we could divide 2 into 5 twice. Now that would leave a remainder of 1. So this is how modulo works. Let's just type this out so we can see. So what are we doing? X modulo 2. Okay, so if x was equal to 5, 5 could be divided by 2 twice, so that would be basically -4, and that would equal 1. Now if x was, say 16, 2 goes into 16 8 times, so that would be actually -16, and that would equal 0. So this is what modulo is doing. Modulo is basically giving a remainder. So it's like, how many times does 2 go into x, and what is the remainder? So if x modulo 2 is equal to 0, and we'll do the same for y. Y modulo 2 is equal to 0, then we're going to instantiate a steel block as well. Okay, so save that out. And I've missed a bracket somewhere. Or, how about an or? No, we want to do it on every odd number, so it's going to be an and. Okay, so x modulo 2 returns 0 and y modulo 2 returns 0. Then we're going to instantiate our steel block. Okay, let's see what I've done. And there we go, that's pretty much what I wanted. Okay, so there's the first part of starting to build our level and store the information of that level in our two-dimensional array.